quick recording just to show how we compute in ISET with human physiological optics. I'm going to just set things up. I'm going to check that we in fact have ISET in the path, and I'm going to initialize the database that manages the scenes. Then I'm going to go get a scene, and I'm going to get a scene. It's a scene of a chess set, and I'm going to model that scene with a structure that is designed to incorporate all the parameters of a human eye model. In this particular case, it's the Navarro model. And there are a whole bunch of parameters that we can specify pertaining to the pupil diameter and retinal radius and so forth that are too much to explain right here, but are part of how it is we model human eye. We're going to set a bunch of parameters over here. I'll get the calculation started. I'm going to set parameters like where we're accommodated to, what distance we're accommodated to, the field of view. We're going to speed things up. I've turned off the diffraction part of the calculation. It'll run and just take a little longer. This first one we ran at a 6mm pupil diameter, and this is a pretty low quality rendering. There's a lot of graphics noise in here. With a wide open pupil like this, you can see that we have, it's pretty sharp up here up close, but quite blurry in the distance. And if we take down the pupil, we know that the depth of field should change. And this is a model of how the physiological optics of the eye would have a change in depth of field when we bring down the pupil aperture. And you can see that it's a lot noisier because, well, we shrunk the pupil down by a factor of 3, so it's 10 times fewer photons, so we get a lot more noise. But you can see how it's sharper back and forth, reflecting what we expect. And we could run it with many more rays and make this thing, well, I'll get it started. We could make this thing look a little bit better, but the basic properties of the capturing the pupil and depth of field and so forth are already shown here. And you can go now, but I'm just going to let this thing run to the end so you can see when we have more rays, it looks a little better.